Hello there. Today we're going to talk about one of the most popular topics for developer, which is testing your software. Especially we're talking about Cypress component tests and how they provide more confidence in our quality. First to myself, my name is Pichler. I'm a person. I'm doing this already for 17 years professionally. I have a strong focus on front-end development. That's why I have a love-hate relationship with JavaScript. And I like geese. They are my power animal. Where do I work? I work at a company called Eurofunk. This is the office located in Salzburg. And what does Eurofunk do? We specialize in providing products and services for control centers. For example, rescue services, fire brigade, and the police. And everything you can see here in the picture is actually provided by us, except for the person, of course. He's working with our equipment. So the desk, the chair, the software, the monitors, everything. We also provide multimedia integration. So you can see here one of the command centers in Germany, where we provided our solution. So even the video wall you can see here in the front is installed by us. So the whole room is designed and furnished by us. And we also do this in the basement. We go into the basement and install the servers, do the cable management, which is of course the most important task that we do. On the software side, we provide a solution which is called EOX, which stands for Eurofunk Operations Center Suite. And this is the software I'm primarily contributing to. Specifically, I work in a department which is called Products Foundation, which provides platform solutions to specific streamlined teams so that they can provide features in a faster manner. And this brings us already to the topic of testing and quality. Some of you know already the testing pyramid. I'm just using it here as an example to make a point or to illustrate a point. So in the testing pyramid, it says that you should do most of your tests at the bottom, which are the unit tests. And as a second level, then you have the integration tests. And the least tests you do on the tippity top are the end-to-end tests because they are the hardest to maintain. And the reason for most unit tests is that they're the fastest and the easiest to maintain. How does it look like for the front-end part in our department? It looks like this. So we have a lot of unit tests, almost no integration tests, and lots of end-to-end tests. We didn't decide to do this. This just happened because of circumstances. And the question to answer is how this could happen. For that, we have to dive into the tech stack we're using for our front-end solution, which is Angular, which provides two testing solutions that you can use. You can either use Jest or Karma with Jasmine. Karma and Jasmine is the default that you get. With Jest, you have to do some custom setup. But both are valid to use. And sometimes writing tests with Angular looks like this in our department because there are some pain points when doing so. And those pain points are test configuration, the DOM interaction, asynchronous, change detection, and HTTP mocks. When we look at the test configuration issues, they are mostly identified by the added complexity by having to understand the Angular module system. This is kind of a little bit rectified now with the newer versions where they are trying to get rid of modules with the standalone feature. Then you need to add all the required dependencies to your test setup. So you need to know how your application is set up and how the component is set up. And you need to provide this to the test bed. Otherwise, your component doesn't work. You have to decide which dependency you want to mock. It's completely open to you if you want to mock everything or just mock certain parts and so on. So this is depending on your strategy on how to test. And you have to mock Angular core features like routing, HTTP, and so on. Then the interaction with the DOM. One of the issues is that it's very, you have to write a lot of boilerplate code to do simple things, like illustrated in this example where we just get a p tag out of the template and try to check what the text inside of this p tag is. So it's not complicated, it's just cumbersome to write. What's more annoying is to work with reactive elements like inputs. So when you want to test that users are typing something in there, you have to know exactly what kinds of events are being triggered by the browser natively, and you have to simulate that by calling the events yourself via JavaScript. This is not always that easy, especially for newcomers and so on that start with front-end development in general. So this is not an Angular-specific problem. Then another topic I mentioned is asynchronous. This is also not a fault of Angular or anything. Asynchronous is just hard in general. So in Angular specific, there is the issue of misusing fake async and async. You use them for different use cases, so you have to understand that. It's difficult to understand in the context of fake async what tick and flush are doing and when to use them. There are issues with native promise syntax of async and await because Angular still uses Zone.js, which monkey patches functions like set timeout, set interval, and so on to build up its reactive system. And if you're using async and await, you're kind of circumventing this, and then stuff just doesn't do what you expect it to do. So this is not working out of the box, and it can be an issue. And it's hard to debug, of course, and misleading because that's just how asynchronous is, different timings and so on, and to figure out when stuff happens and so on. Then I mentioned change detection. Recently I heard it's not called change detection anymore. It's actually called synchronization in Angular. But I still call it change detection now because it's easier to understand for everyone. You have to manually trigger change detection in some cases because the change detection in the test does not exactly work how it does in your application. Then there can be timing issues, of course, with asynchrony. That ties into the thing that I already mentioned, that these two together make it even more complicated to deal with. And you have an increased complexity and pitfalls when you use on-push change strategy. On-push is a way for Angular components to optimize the performance during this whole change detection algorithm. And I mentioned HTTP mocks. It's adding complexity by introducing the HTTP testing controller, which is provided by Angular itself. You just have to learn it and so on. Again, handling of asynchrony ties in again because it adds complexity. And now we have three things that work here: change detection, HTTP, and asynchrony in general. And mocking of error responses isn't that straightforward as someone might think by looking at the API surface of the HTTP testing controller. So what about the end-to-end tests in our case? We have lots of them, and for that we use Cypress. The question now is, what is Cypress? Cypress is either a tree or the tool that we are using, which is used for end-to-end testing. It's a test runner and also a test framework, and I have here an example how it looks like. This is the test runner where you can select a test. It then will execute the test steps, and you can see on the right side it has to navigate to a website that's being deployed, and then it's going to interact with it like it does, like a user would interact with the website. Currently, we have around 1,000 end-to-end tests. I just did a dirty search on file namings, so it could be that there are more. And I also only searched in our project. We also do end-to-end testing in other departments, of course, and in other projects. And because we have so many end-to-end tests and we have so much knowledge with Cypress, we thought maybe we can do end-to-end tests. Use the end-to-end test framework to do integration tests on the front end with another tool, which is called Storybook. In case you don't know what Storybook is, Storybook allows you to develop components in isolation, independent of the application environment. So you can showcase the components, play around with them. You can also use it for documentation purposes. And you could then run Cypress against this Storybook instance to do an isolated test of a component. That sounds very good in theory, and it also works to a degree. So our CI pipeline that we set up looked like this. So in the first step, we built Storybook so that we get build artifacts out of it. Then we started a node-based HTTP server, nothing special, that would use the artifacts of the build from Storybook to serve it. And then we would build Cypress, which is the start process of Cypress, where it also builds the tests. And then we would start the tests, which would go to the local HTTP server that we just started in process of the CI pipeline and do the tests. Worked great. There was just one issue. It took a very long time. We're talking about 10 minutes plus for just a couple of tests. So all these starting of the Storybook build, the HTTP server wasn't that much of an issue, but doing two build processes and also Storybook back then in version 6 wasn't really that fast for some things, and yeah, it caused not such a nice experience for us, especially on the feedback cycle. Took too long. So this in general brings me to the pain points of end-to-end testing. First of all, we all know they are slower than unit tests or integration tests because they have to simulate real user interactions, and with this reactivity you have more wait times. You have longer feedback cycles, so it slows down the development process even further. So in our case, the end-to-end tests that we have, they don't run with the CI. They run independently multiple times over the day in a certain schedule. And then you get feedback, a couple of hours later after you have deployed your feature, which is also not nice because of the context switching when you do multiple tasks. Flakiness is always a topic. This is not a problem with Cypress or anything. This is for every end-to-end test. Because it's just, there are so many outside factors that can cause a test to fail. Yeah, because you have a very complex environment depending on your product. So network issues can happen. Any hiccup basically in one of your modules can cause a test to fail. But flakiness erodes the confidence in your tests, which then you have no idea what the quality of your product is. I already mentioned the complex setup depending on the product you have. So in our case, it's a very complex setup. You need a lot of things running. Debugging comes also with the complexity of your setup. It can be that, you see the issue in the tests and it is not that obvious what failed. Then you have to go and dig into the logs of the system and so on and so on. It's like you're debugging a real production environment instead of just an isolated thing. Takes time. Then the infrastructure in the terms of cost. So in our case, we can't test on our production systems. They are isolated on the customer side, so we don't have access to that. So we need to set up our own test environment that's very close to a production environment, and this costs money in hardware, resources, and stuff like that. And test data, managing not real, but test data that is realistic, is difficult, so that you get better test results. This brings us now to Cypress component testing. This is now this intermediate layer between the end-to-end side and the unit test side, where you can test components in isolation with Cypress itself. The frameworks that are currently supported are React, Angular, Vue, and Svelte. At the moment where I was preparing this presentation, if something would change there, there's a link here that you can follow to see if a framework was added in the meantime or not. So what are the pros and cons of Cypress component testing? You can test components in isolation, like in unit tests or in this Storybook scenario that I described. You get the precision and control of unit tests. You have no asynchronous management because this is completely handled by Cypress itself, like it is for the end-to-end tests. So you don't have to do the reactivity stuff yourself. You have no change detection management because the component behaves like it's in the application and not in just some isolated test environment. The developer experience is great because you have this runner that I've shown you where you see exactly what Cypress is doing. And if you do it in the CI, you can record videos of this UI, or you can get screenshots if a failure happens and stuff like that. So this is really, really nice to do. And of course, the speed is increased because you drop a lot of the complexities that end-to-end tests need. You don't need an environment set up for that. You get rid of the whole backend side and so on. So yeah, it's really fast. But there are still some cons. What doesn't go away is the test configuration. So like in the unit tests, you need to know how to set up your components so that it can run. Time control with Cypress, meaning that you can take control of the clock if you want to do more precision testing with datetime. It kinda has conflicts with the change detection algorithms of Angular and React. There is a bug ticket for that open, but wasn't addressed yet. And tests without DOM interaction don't make sense to do in a test framework that's specifically designed for UI testing. Right. And after we have migrated, our CI pipeline looks like this. So we removed the whole storybook and HTTP server part. We only have Cypress, which is then a single command to start and execute the tests. And if we look at the new times, we have a project where we have around 259 tests. They are executed in the CI around 3 minutes. So this is compilation plus runtime. In the development, you only compile once, and then there's a watcher on your files, and it only recompiles what changed. So a complete runtime of all the 259 tests is like 1 minute, but if you're locally developing, you're focusing on one test, and the test time is in the seconds there. So our goal in general is that we have a feedback in less than 5 minutes in our pipeline for a job. So this is well within our parameters, and we like that. Yes, and now I have a demo prepared where I can show you a sample implementation of Cypress component tests. For that, we do a quick switch here. Right. So first, let me show you the sample application that I have prepared. Let me quickly start it up. Right, so I have this example, which is just a login form into a company which is called Goose Corp. You can enter any data here. You can see that we have live validation that's happening. And if I enter an email address here and some password and I hit login, you see that there is a delay for a few seconds, and then you get a feedback in a banner that says you have successfully logged in or you didn't do that at all. Right. And now I want to start the tests for this. So we have Cypress installed. The first thing you're greeted with is, do you want to execute end-to-end tests or component tests? So you can see they are separated in the UI here. We do component tests. And once it has done that, you can select the browser of your choice. So you can see that you can even test in different browser setups to see if something is broken in one of the browsers regarding styling or behavior. So let's just select the default with Chrome here. And you can see here now I see all the tests that are available in this project, and I can select, for example, this one test here that showcases like a full test for this component, and the runner just runs through all the test steps and is executing those tests. While we wait for that, nice, it's done. You can see here that we see all the individual tests that are being executed. And now to show you a little bit about the debug experience that I mentioned, you can open up a test here, and then you see all the steps that are being executed in the test itself. So for example, here you can see that it queried for a specific element in the DOM. And if I click that, or even if I just hover it, you can see here on the right side that the element is already being highlighted. So which one I'm targeting. So I can click that, and then it's pinned, and I can open the debug, the developer tools here. And you can see that, it will immediately print out, what I've pinned, all the information that it has regarding that. So how many elements were matched and what was returned and so on. So this is really good for debugging. And also you get kind of a timeline here. You see the state of the component during this test step. So if I go further here with this type command, you can even see for typing it required to do a click, and you can see where the click was done on the input element itself. So you can even control where on the element it should click and so on based on the coordinates. Great. This is for the debug experience, and now for some examples and code. So how does a structure of a test look like? So you can see here a Cypress component test uses the standard terms like describe here, before each and it. So you have those also in unit tests. So the syntax of a test or the structure of a test is completely the same. So very familiar for every developer. And the first thing you do in a test is here you mount a component into the environment of Cypress. And in this case, we are mounting our login form component. And now we are coming to this point I mentioned. You need to know what your component needs to run. So we have here the setup with the providers where I need to add the configuration for animations because the components that I'm using need animations. And also we have an internal icon library. So this is this provide icons here that we are doing. And to interact with anything, you can see here that you have this cyget command where you can use the jQuery query syntax to get any element on the page. And then you have different assertions here, like be visible, that you can then execute against this element. These are not magic strings, because I get the question sometimes. If I do a period here, you can see here I get auto-completion for the available assertions that you can do. Right. So yeah, the first test is basically just checking, is it available, the component? And in the second one, that's more interesting. We are doing more interactive stuff. For example, we are typing here. So what Cypress is doing here is really simulating a user typing each individual letter into the input. And each individual letter will also trigger the right events for you that, validation is triggered and stuff like that. So you don't have to take care of that. So it's like in a single command. Clicking something very easy, right? What Cypress is also doing for you is checking if an element is even clickable, meaning it checks, is it visible? Is it being overlaid by something? And it will throw an error if the coordinates where you try to click it won't produce the click event. So there's an algorithm in there that it will do for you. Yeah, and if you do any assertions, we have already shown that with the should syntax. But you can improve that. You have to type a lot regarding queries and so on. You can write something called custom commands. And you see here that the mount function was reduced because I created a custom command that already sets up the base stuff that every component would need in my test environment, like this provide animations and provide icons. So if we go to the definition here, you can see here that we have this merging of configurations happening. And up here, I have these default providers that I merge into that, and it's always being provided. So I don't have to take care of this anymore. Another custom command we added was this get by QA. So I don't have to write this data QA syntax all the time. I can just focus on the name that's being provided into this data QA stuff. Right. So this is for custom commands. Next interesting question is, how do you pass data into the component? So if it has inputs, how do we provide that? So Cypress in the mounting has a thing called component properties where you can set up the component and bind things to it. In this case, I provide a custom info message, and this info message is up there. So it's hello there instead of the standard question or message. And if you want to do live updates, so while the component has already been mounted and you want to change the input during runtime, this is possible now with signals. Big topic, you should look that up. I'm not going to go deeper into that. You can provide a signal as an input here, like I'm doing here. So I create a signal, I pass that signal into the setup of my component, and later down the line, I have here where I set the signal to a new value, and then it will live update, and change detection happens automatically and things like that. Then we have event handlers. So this is outputs So Cypress provides a utility function called create output spy. So I have a output on this component which is called after login. And with this create output spy, you create a spy object from Cypress, and you can access it later down the line with a specific syntax, which is here this at after login. So it uses the same name as as I've provided up there with the util function. And then you can do assertions against this spy like you're used to from unit tests with, has it been called once, has it been called with certain parameters, things like that. Great. What else do we have? We have also the template syntax, which is very helpful if you have components that work together. A classic case would be an accordion with accordion panels, where you want to do an integration test between those two. Then you can use this template syntax where you set up two components and then you provide a string as a template where you use the normal syntax from Angular. You bind the inputs and outputs as you would do usually. And then you get that in your test environment. One thing to note here is that the properties, so component properties do change here. So they are not anymore what the component, because there isn't one. There's a generic host component that's then available, and you can define an interface with all the inputs that you're providing. So I have an interface that says, okay, I provide info message and then after login spy to be bound to that I can then use to bind in the template. Right. Okay. And another example we have is accessing the component instance itself. So with that, I mean the created instance of the component in the code. So when you mount a component in Cypress, you get this, what they call a wrapper object, which contains two properties. One is the fixture, which is the test environment instance. And you can use that, for example, to get the injector, which is used for dependency injection in Angular, to select a specific service and interact with the service, or create a spy on the service, or things like that. And another thing that is provided is the component instance itself. I'm not showing this here specifically. So if we go, yeah, doesn't matter. Yeah, but there's also the component instance itself on this wrapper. And you might access it for different reasons. You might have a static property that you want to check and assert. Right, and then we have mocking. Specifically, I'm talking about here HTTP mocks, because some component at some place is gonna talk over the network with something. And usually in tests, you don't want those tests to go over the network, because you might not have internet on the CI and so on, and also wait times and so on. You don't want that. There are multiple ways to do that I have implemented here. One of the easier ones is you just override or mock the service that's doing the HTTP call and provide some mock data. Another one is to actually use the Angular HTTP client. I just did it to show that it is possible. I wouldn't do that. But yeah, you do this, this provide HTTP testing client here. Then you have to get the testing controller. You have to then set up the mock basically for the function, and then flush the data. I wouldn't do that. It's possible to do it though. And another way, which is probably the right way in this case, is to use Cypress intercept functionality, where you can do the following. You can provide a pattern for a URL, and you can tell it what it should do as a response. You can even give it an alias. So this is the same as with the spies. And later on, you can access the alias and wait for it. So this is telling Cypress, hey, wait for this response for this request to return a result. And once this has happened, you can safely access the DOM and do your assertions against the UI. Right, so those are all examples. That's it then from my side. I hope you saw that Cypress component tests are a great tool, especially to fill this gap between the end-to-end layer and the unit tests. We certainly enjoy using it. As you have seen, we have written many tests already with it, and we're looking further to increase the confidence in the quality of our code. Thank you.